So let's talk about AI reliability. And in 15 minutes, it's very hard to go in depth on the whole topic. But what I really want to talk about is about source of the failure and possible mitigations. Like, what actually is different when it comes to what you can expect from software. Now, let's start with the place where we currently are. I think that large organizations are running AI for the 2 decades right now, like with a quite major approaches to both MLOps and LLMOps. But a lot of organizations are currently at this stage. So like they started to introduce AI like through Copilot, through like, co-creation, AI assisted tooling. And this is all relatively low risk. And with the growing risk, like the practices you need to introduce are much more complex. So the next big thing is really agents. Like everybody expects it to become like the next phase of adoption, and it's slowly happening. There's like a lot of talks around the adoption of agents, but those agents currently which are shown are still in fairly controlled areas. So what I mean by that, you can find like agents constructing reports or agents creating dashboards for like analytics, but they are still not in highly risky areas or like mission critical systems. I want to have like, a clear understanding and I share with you what I understand as like reliability. And this is really about like a consistent performance across different scenarios. So you want to put like the different data into the model or the system and get like trustworthy results. Now, I think a lot of things that you hear is about test, and evaluate. And personally, like the worst enemy when I was operating like those systems in production was time. Like this was what was causing like the most problematic failures in those systems that I saw. So this is like how we were operating for like more than 3-4 decades. We were like gathering requirements, change it into the rules, combined with the data, like we optimized the whole process of like developing the software, and then users were getting like the answers through the system or the integration. Now, it's still, and the testing was focused around, does it work as defined, really? So, like we are moving here, and what's happening is that you get the same kind of issues that you can get in software. So the failure in security, performance, latency, all of this is still like you can still see that. But like the switch of answers and getting actually rules, like so you get like a fixed model, and it does not really matter if we are talking about like a large language model or we are talking about recommendation system. It's fixed in time, and the world is not fixed; it's moving. So what's happening? It's that we can see over time quite a lot of different drifts. And those drifts that are listed are not full list. There's like plenty of more. But to give you some explanation. So data drift, you can see like a different data, different questions like that are flowing to your model. Concept drift, let's pick fraud detection systems. And it does not matter if you are doing a fraud detection in form of large language model that's actually checking documents for like, certain patterns. Or if you are doing it on time series data, it can still happen that people conducting fraud activities will change the behavior, and then you have like both change on input and output. Your predictions will be different. If we are going to prediction drift, you can notice, for example, that you are seeing. Let's stick to the fraud example. You are seeing a growth in responses for the fraud. And it may be indication that you have like a concept drift. It can be indication that there are just like, more fraudulent activities are being happening. It's really hard to say without further analysis. One more interesting, and I think especially based on the previous talks, is bias drift. So usually when people talk about the bias is something that you are checking in training of the data. You are trying to remove it. But what can happen is that when you are introducing like AI system, it actually teaches people to react and adapt and then like introduce new biases. So like those are a complex set of things that can happen. And just to put it into like perspective, what does it mean like if you are running a mission critical system and you are hitting this kind of failure? So Zillow is company that was gone public in 2011. What has happened? They were advertising their machine learning capabilities. They were like pricing 70 million houses in US. And 10 years later, 2021, they are so confident about what they are doing that they allow cash operations for certain houses. Fast forward 6 months later, the company has like a massive operational loss. 2,000 people are losing jobs, and they are pretty much closing the whole part of this business. Now, this system was not monitoring for any of that. Like the housing market was like hot for a very long time. It became like, started to be calmer, and the algorithm still was buying those houses quite for the overpriced, buying for the higher price than it should. So this is like at scale. If you automate, just example where you can get, and we have tools to actually find the drift. So no matter which kind of like cloud provider you're using, if this is AWS SageMaker, if this is Azure AI Studio, there are tools that will allow you to set up like the monitoring for the drift detections. Like some of them require you to set up like the baseline for the statistics, like how the data that you see is different. Some of them require you to gather ground truth, so like people will have to be involved to actually provide like the expected values. But you can find this. This does not solve yet problem of if you will find it, you still need to have like plan B to actually operate. Like it's not, algorithm will not be able to adapt on its own to like changing conditions in many situations. Let's switch a little bit angle, because I was talking about like change from the outside. Now let's talk about the change from the inside. This is typical retrieval augmented generation. So you have user interacts with the interface. There's some kind of orchestration framework that pulls data, combines it with like large language model outputs, and then you are getting those responses to the user. Now I think there's like a massive focus around accuracy of this process of orchestration, like retrieval of the data and actually passing it to large language model. I'm nuked like every day for the examples, like how people are improving that. So let's look at simple case just to show you how like data is really important here. I've asked ChatGPT to behave like as a Harry Potter expert, and told it that I will supply the quotes. So pretending a little bit of a RAG application, I'm supplying a quote about Fluffy. So this is like a dog, Mr. Hagrid's friend, and ask a simple question: how many heads dogs have? And I get answer 3, which is like far from ideal. And it shows two things. One thing is like I'm actually asking out of context questions, so it's probably like wider than the system can deal with. But it's also about like the quality of data. And a lot of examples that you see when it comes to like data and retrieval augmented generation is about static data. Static data does not exist in majority of like use cases that we see. The worst failure I was experiencing in production was actually related to extremely small change in data in one of the tables that we used for the recommendation engine. So like this change like completely overhauled like the responses. And we've ended up in a situation where for men we were proposing brass, like, again, far from ideal. And so like data quality and data monitoring has to be like, part of the protections for those kind of mission critical systems. In that case, what we actually did is, this was on Databricks. We've introduced data monitoring capabilities, like there's a built-in monitor. And then like we started to think around how we can deal with this failure gracefully for the users. So we've redesigned like the process around it. When we were spotting some of like those kind of failures, we were disabling parts of the system. We could not actually roll back to the past because of availability and freshness of the data that was proposed, but we were disabling part of the system one after another until like, just basics remained. So this is a little bit of a story that if you have like, those failures, it's not always like easy to react in a way that's like in software. Let's add like a new instance. You will need to deal with it in a different way. Like one more thing that I want to mention is that those systems, like currently large language models, are generally just like unreliable. Like there's like a lot of research that shows that hallucinations are part of the transformer design. So like you need to have like those kind of fallback mechanisms when it is failing. So let's take example of agents. Customer support agents is like a big thing recently. And some of the companies are actually introducing stop conditions to how they are handling it. So you have like an agent that works with the customer, but there's like a deterministic process that will break it as soon like, a limit of messages, certain words will show up, like, or they will detect that he's like starting to loop through similar responses. And it will immediately break out of like this loop and route like the traffic to the person that will do like a customer service further. So this is really key about like thinking, yes, we can find the failure, but we need to have like a ways to fail gracefully eventually. And one more thing that I want to highlight about like the system design. This is like a fresh research. So it was released in August. I think like what people see with large language models is that, oh yeah, it can do like maths, it can do like, all sorts of complex things. Now, this research is actually showing like the diverge between like, hard skills that it is acquiring and simple and medium complexity skills. And it was showing that like when we are moving from GPT 3 to 4, like or Llama 2 to 3, actually like, the performance and reliability on simple cases dropped because the models are taught to answer to all questions. They are not being taught to like, to have like a privilege of doubt. This is not their thing. So they will like respond even if this is plain wrong. So one other angle that I would look at it is really about like narrowing the scope of your AI system as much as possible. Like in this case, like, I've took the Harry Potter example and asked it to not respond to queries to the real world. And it allowed me to like, protect or like, minimize the scope of access. This is like a simplistic approach, but it's really about like narrowing as much as possible, like, the scope of the failure that can happen. And this is the things that we can do right now. So if I would have to summarize it is, like there's loads of things that we can do. and we can really push the use cases. But you need to understand your risk model. Like from this risk model, you need to understand what components you need to monitor, and the data is like also the part of the things that can change around those systems. Like narrow the functionality, like, and think about how to gracefully degrade or fall back from the failure scenarios, because like when it will hit in the production, this will be really like problematic. And there's like a whole bit that I wanted to also cover around the deployments, but I will be around the booth, so if you want to talk about this, like I invite you. Thank you.